In this video, we're going to find the mean of a negative binomial and its standard deviation. A negative binomial allows you to model and find the probabilities for the number of trials needed to run an experiment until the kth success occurs. Here we're going to use a negative binomial that gives R1 success and X failures in X plus R minus 1 trials before the X plus Rth trial, which is denoted by the combination expression. This PRP is given by the combination X plus R minus 1, R minus 1, Px to the P to the power X and 1 minus P to the power R. So to get the mean, it will be the summation from X is 0 to infinity, X times the combination of X plus R minus 1, which gives the probability of X at that point. Then we try to simplify the equation by pulling out the summation of X at 0, which is here, and we add it to summation from X is 1 till infinity, which we simplify. 0 cancels out the whole of this, and we're left with this equation, which we further simplify. The x's cancel, giving us this equation, which we term as equation 1. Now from equation 1, we see that 1 over r minus 1 factorial is equal to r over r brackets r minus 1 factorial, which is the same as r over r factorial. And also see p to the power x can be expanded, and you get p1, p negative 1, and px is equal to p power 1 and p to the power x1. And also you can see that you can also expand 1 minus pr, which you get 1 minus pr to the power r plus 1 minus 1. And you pull out the 1's, then it gives you this expression after. Then we later on equate these new expressions into equation 1, which when you put them inside the new equation 1, you pull out the constants, put them outside, leaving us with this inside, and you equate that to equation 2. Then from there we can say let w be equal to x minus 1. If x is equal to 1, w is equal to 0, then x is w plus 1. And let s equal to r plus 1, which is equal to r is equal to s minus 1, which we equate into equation 2. Which we simplify to give us equation 3. And from here we can see that summation of w is equal to 0 to infinity, w plus s minus 1 factorial over s minus 1 factorial w factorial p to the power w 1 minus p to the power s is equal to the summation of w is equal to 0 to infinity, p ws is equal to 1. This is the equation for getting the probability. And to prove that it's a PMF is 1. So that part is 1, meaning that you equate this into equation 3, leaving us with rp brackets 1 minus p to the power negative 1 dot 1, leaving us with the mean as rp over 1 minus p. So now to get standard deviation, you first need to get the variance. And the variance is equal to the mean of x squared minus the mean of x to the bracket squared, which is in the first term, and we already know our ex, which is rp over 1 minus p. So then we have to find the ex, the mean of the x squared. So now ex squared is equal to the summation of x is equal to 0 to infinity, x squared times the formula to get probability of values in a negative binomial. So we can see we can pull out 0, the mean at 0, giving us this expression plus the mean from 1 when x is 1 to infinity. Then it leaves us with this, because the 0 nullifies this. So we can further on write it as a combination expression, which is this. And we can expand it, which we can simplify r1 cancels out with r1, leaving us with this expression down. And we can later on pull out an x so that it cancels out with this squared, which you can see on here, leaving us with this. And from this equation we can say that r1 1 over r minus 1 factorial is equal to r over r brackets r1 r minus 1 brackets factorial is equal to r over r brackets factorial. Because you can say px is equal to, you expand it, it gives you p to the power 1, p to the negative 1, p to the power x, which can be later on as well as p1 times p power x minus 1. And also you can see we can also expand 1 minus p brackets r, which we can add 1 and subtract 1 to the powers, leaving us with this. And later we can pull out that negative 1 to give us this, which we later on we use those expressions we got and put them into equation 1, which when put in this gives you this. Then we have to pull out the constants to be rp brackets 1 minus p to the power negative 1 summation from x is equal to 1 to infinity x times brackets x plus r minus 1 factorial over r factorial brackets x minus 1 factorial px minus 1 minus p rt, which gives us equation 2. Now we let w is equal to x minus 1. If x is equal to 1, w is equal to 0. So x is equal to w plus 1. Then s is equal to r plus 1. Then r is equal to s minus 1. We substitute this into equation 2, giving us this expression, which will later on expand you to the w plus 1 so that you have individual summations. So now from this we can say the summation of w, from this expression we can say the summation of w is equal to 0 to infinity is equal to w plus s minus 1 factorial w factorial pw over 1 minus s. You remember how they write the you remember how they write the expression to get the probability at a point. So it will be equal to the summation of all the probabilities, which is equal to 1. because the negative binomial is a PMF. And also now, from equation 2, we can see that summation from w is equal to 0 to infinity, w to the brackets, w plus s minus 1, close brackets, factorial, s minus 1 factorial, w factorial, p to the power w, 1 minus p to the power s is equal to the mean, which is equal to sp over 1 minus p. Then we get these and equate them into equation 3, which gives us this, which we will simplify. Until we get the mean of x squared, which is equal to rp over 1 minus p squared, brackets, rp plus 1. Now we can get the variance. Now put it back into the equation of the variance, which will give us rp over 1 minus p squared. Then standard deviation is got by the square root of the variance of x, which will leave us with square root rp over 1 minus p